Hey guys, it's Miss Powers. This is one of the first times you've seen me without a mask in a long time, so I don't have any makeup on, but I did curl my hair for this video. So, I am really sorry I can't be there with you guys. I miss you a lot, but, last week after Christmas, our whole family tested positive for COVID. So, I'm doing okay. My family is mostly doing okay. My mom, is a little sick. She's currently at the hospital, so hopefully she'll be getting better. But the rest of my family is okay. I am a little bit stuffy and have some congestion. So during the video, that's what that is from COVID. So, but we're just going to continue on as usual. In this video, I'm going to have you can't answer my questions, obviously, out loud, but sometimes I will have you look over to a partner and, say, talk about this. What do you think about this? Just really quick with a partner. If at any time you need to pause the video, just pause it, catch up on what you need to catch up on, and then start it again if you're behind or something. For this video, for these notes, I didn't have time to print them out. Obviously, I had a foldable, but I'm not there to make copies of it for you. So you are going to need a piece of graph paper and a pencil, and if we're going to be graphing lines, so if you're a perfectionist and you want to have a ruler, you can get that as well. And if you're a color coding person, you might need some colors as well. So graph paper, pencil, if you want a ruler, and if you use colors. That's what you need today. So let's get right on into it. Alrighty, today we are going to be talking about something new. It is called systems. Well, let me go back. We're going to be solving systems. Oh my gosh. By the graphing method. And I'm going to talk about what that means here in just a minute. So I'm kind of letting you on your own for these notes. It kind of looks like I have a graph paper, but as far as what goes on the front, what goes on the back, that's kind of up to you. But I will tell you, you might want to write sort of small, and we will be making some graphs. So just keep that in mind. First thing we're going to do is define a system of equations. So right here, system of equations. What does that mean? We have not heard that before. What that means is we're going to have more than one equation at the same time. More than one equation at the same time. So we're still talking about y equals mx plus b, so y equals 3x plus 2, and y equals 7x minus 5, whatever. Two equations. You can have three, but today we're just going to do two. And what does solve them mean? What does it mean to solve a system? To solve means to find an ordered pair. Find an ordered pair, and an ordered pair is an x and a y in parentheses like this. So all of our answers are going to be ordered pairs. And that ordered pair will make both equations true. And what that means is, if I had an equation that was x greater than 4 and x greater than 5, something like that, I'm just making it up, then 6 would satisfy both of the equations. 6 is greater than 4 and 6 is greater than 5. This is kind of like that, except it's an ordered pair that will, if you plug the ordered pair back into both of the equations, it both equals out, if that makes sense. So there are three methods to do this. We're going to do a week for each. So this week we're going to do the first method, next week we're going to do the second method, and then the week after that we're going to do the third method. And the first one is called graphing. We love it. But good news, if you don't like it, the second two do not involve graphing whatsoever. Second one is called substitution. And the third one is called elimination. This is one of my favorite topics ever. I love systems of equations. So today we're just going to be focusing on graphing, which is the easiest one. So I'm going to write all pretty. I'm going to write graphing over here. Or below, wherever you want, just so that we know this is the graphing method. So we're going to do a couple examples. We're going to do 4 examples, so it's up to you how you space them out. Do you want to do 2 on the front, 2 on the back? The first one is a little bit longer, so do you want to do 1 on the front and 3 on the back? It's up to you, but you need to space them, appropriately, okay? So example 1. Example 1's just longer because we're going to have the steps with it, but the other ones are shorter. Example 1, we're going to solve the system. And the system is, the first equation is y equals negative x plus 3. And I like to put a little, I like to number my equations. So that's equation number 1. I just put a little number 1 above. And the second equation is 4x minus 6y equals 12. And that is equation number 2. So let's go over our steps. Step 1 is both equations must be in y equals mx plus b form. Okay? We have to do that in order to graph. We've already done this. We did this for our final. We did this several weeks ago. But basically, so this is what I'm going to do. This is equation 1, which was y equals negative x plus 3. Is that one in y equals mx plus b form? Lean to a neighbor and say yes or no. Is this one in y equals mx plus b form? Tell your neighbor. I hope you said yes, it is. So we're going to leave that one alone. However, this one, 4x minus 6y equals 12. Tell your neighbor, is that one in y equals mx plus b form? No, okay, obviously it is not. So, little recap, how we do this is we want to get the 6y by itself. So we're going to take the x over to the other side. So it's positive, so we subtract on both sides, and it cancels from the left. So now the negative 6y comes down, and we bring these both down one at a time in the correct order. Tell your partner which one should go first, the 12 or the negative 4x. Tell your neighbor. And tell them why. Why should that one go first? Okay, the answer is the negative 4x should go first, and then the positive 12. And the answer why is because we want it to be in y equals mx plus b form. So the mx comes first. Then we divide everything by negative 6, every single thing. So cancel, the y comes down. Over here, we want to make sure we reduce our fraction. So 4 over 6 reduces down to 2 over 3, and 2 negatives make a positive. So positive 2 over 3 with the x, and then a positive 12 and a negative 6 makes negative 2. All right, now both of these are in the correct form. I am going to color code them so that when we graph them together on the same graph, we can tell them apart. So this one's going to be blue. And this one's going to be green, and I'm just going to underline them. So this is where you use your colors if you would like to. And one more thing, I'm going to label my M and my B just to help me graph. So the slope here is negative 1 over 1. We always like to have it as a fraction. And the B is 3. Over here, the M is 2/3, and the B is negative 2. All right, so that's step 1, is to make sure they're both in the correct form. So step 2 is to graph. Again, if I'm going too fast, pause the video, ask questions or something, and then start it back up when you're ready. Step 2 is to graph. Graph, let's finish this, on a coordinate plane. Graph on a coordinate plane. So I'm going to make my little graph. You only need to go to 5 on all sides. So when you start in the middle, go up 5. Whoops, I didn't go down far enough. Go over 5. Go down 5. And go left 5. Okay, and I'm going to number mine too really quickly. Oh my gosh, these aren't negative. What the heck? Okay, so very quickly, there is my quick graph. I'm going to do the blue one first, and we're just going to graph it like normal. So the B is 3, so we start at 3. So go up 3 and make your little dot. And the slope is -1 over 1. So down 1, right 1. Down 1, right 1. And this is why, keep going, this is why I had you go all the way, both sides, up and down, all the way. Instead of just making 2 points, I made you go all the way. This is why, because we don't know where these are going to, they're going to intersect eventually, but we don't know where. It could be at the very bottom of the graph, or it could be right in the middle of the graph, but we need to go all the way to both sides, up and down, because we don't know where they could intersect. So let's see the other one. Green starts at -2, so I'll make my dot there. And then up to 1, 2, over 3, 1, 2, 3. And see, there they intersect. I'm going to do it one more time. Up to 1, 2, that one goes off the graph a little bit, but that's okay. See, here's the other one, but I didn't know where they intersected. They could have intersected all the way up here, and I don't know because I didn't make my lines long enough. So you need to make sure your lines are long enough. So that's step 2, and step 3, I'll just write it down here. Step 3 is to find the intersection. Find the intersection. Where do they intersect? And we're going to write that as an ordered pair. Right here is where they intersect. And that ordered pair, let's see, how many did I go over? 3. And how many did I go up? 0. So 3, 0 is the intersection, and that's actually the answer too. So the solution to this system of equations is 3, 0. Now, it looks like a lot of steps, but it's really not, okay? Because sometimes they'll already give you the equations in the correct form, and you just have to graph them, and that's it. Plus, we have to make our own graphs today, so it's a little bit harder, but usually I'll give you graph paper, or like a graph already on a piece of paper that you can use. But anyways, all right. So, do you remember when we were solving equations, we usually had 3 outcomes. You could either have one solution, or what were the other 2 outcomes? Tell your partner really quick before we do the next example. You could have one solution, or there were 2 other options. 2 other options. What were they? Okay, hopefully you should have said infinite solutions, right? You remember that? Infinite solutions or no solution. Well, guess what? It's the same thing here. This is if you have one solution, and we said what it was, 3, 0. Now we're going to look at 2 more examples that have either no solutions or infinite solutions. So if you're not on the back already, go ahead and flip to the back. I lied. I was going to do 4 examples, but I changed my mind to 3. So, this is example 3. 2. All right. So, we're going to solve the system. And the first one is -8x plus 4y equals 4. And again, I'm going to number that number 1. And the second one is y equals 2x plus 1. And that is equation number 2. So, step number 1. Are these both in the right form? One of them is. I'm going to come over here and write y equals 2x plus 1. That one's good. So I can leave that. But this one is not. So let's fix this one. Negative 8x plus 4y equals 4. Alright, let's fix it. So we want to get the 4y by itself. So take the 8x over. Add it because it is negative. Add 8x, and cancel. The 4y comes down. Now remember, which one goes first, the 4 or the 8x? Should be the 8x. So 8x comes down, and then the positive 4. Then we want to get the y by itself, so divide every single thing by 4. And let's see what we get. The 4's cancel on the left, and here we go. 8 divided by 4 is 2, so 2x, and 4 divided by 4 is 1. Alright, so take a minute. Look at the equation that we just got, and then look at the other equation, equation number 2. What do you notice about those two things? Tell your partner. What do you notice about them? Hopefully you said they're the same exact equation. Okay, so this one technically is blue, this one's technically green, but guess what? They're the same exact thing. So, really quickly, I'll just do it in black, I guess. I'll do the M and the B, and it's the same for both of them, so I'm only going to do it one time. The M is 2 over 1, and the B is 1. So step 2 is to graph. For this one, I'm only going to go to 3 on all sides. So I'll start in the middle, go 1, 2, 3 up, 1, 2, 3 right, 1, 2, 3 down, 1, 2, 3 left. And I will label again, but that's up to you. And I'm ready to graph. I'm just going to do this one in pink since they're the same exact one. We only have to graph it one time. So first we start at B, which is 1. And then the slope is 2 over 1, which is positive, which is up 2, right 1. Or down 2, left 1. And we only have one line. So if this, let's just pretend. Let's pretend this was the blue line and the green line. How many times would those lines intersect? How many times are those lines touching each other? They're literally like the same exact line. They're on top of each other, basically. So they intersect everywhere. So how many solutions is that? Do you think it's none or it's infinite? This is infinite. Infinite solutions. Okay, so number 3, what is the answer? It is infinite solutions. So if you see something and it's the same exact, that's kind of the same thing whenever we solve equations. When we solve equations, we get the same exact thing on both sides, like 4 equals 4, or x plus 1 equals x plus 1. That's infinite solutions whenever we solve equations. Same exact thing. Same thing equals infinite solutions. All right, we got one more, and obviously this one's going to be no solution. But how do we know that? Let's do it. Example 3. This one really is example 3, promise. All right, solve the system. Here's our two equations. First one, y equals 3x minus 5. That one's already ready to go. We love that. I'll number it number 1. Equation number 2, negative 6x plus 2y, I went crazy there, equals 8. And that is equation number 2. So step 1, put them in the right form. y equals 3x minus 5 is already in the correct form, so praise God for that. But this one is not, so let's write it and let's fix it. We want the 2y, the negative 2y, to be by itself. So let's take the x over. Hopefully you know what you're doing by now. Plus 6x to the other side and cancel. Negative 2y comes down. Which one goes first? The 6x. Then the positive 8. Then we divide everywhere by negative 2. Everywhere. And cancel. So 6 divided by negative 2 is negative 3x, and 8 divided by negative 2 is, oh, did I do something wrong? Shouldn't be negative 3. Oh, yes, I did. This is supposed to be a positive. Sorry. See, you would have caught me there, but I'm not there for you to tell me, so I had to catch it myself. Okay, my bad. It's fine. So that should be a positive 3, and then this should be a positive 4. That's the only thing that's different. Okay, my bad. So now, what do you notice? There should be a similarity between this new equation and equation number 1. Tell your partner what that similarity is. What do those two have in common? Use good vocab here. Don't just say they both have a 3. What does that 3 represent? Okay, hopefully you said they have the same slope, okay? So this one's blue, this one's green. I'm going to label the slopes and the y-intercept. The slope is 3 over 1. This b is negative 5. The slope is 3 over 1. This slope is 4. When two slopes are the same, what does that mean about the lines? We did this before break. They're not perpendicular. What are they going to be? They're going to be parallel, okay? So, number 2, when we graph, hopefully these lines are parallel. Remember, parallel equals same slope. This one we're going to go to 5 again. So start in the middle somewhere and go up 5, right 5, down 5, and left 5. Labeling is optional. I just like to do it. Okay, so let's graph. Blue equation starts at negative 5, so I'll put my dot there. And then 3 over 1, so up 3 and right 1. Up 3, right 1. Up 3, right 1. Go as far as you can without going off the graph. So that is the first equation, the blue one. Then green, start at 4 and go up 3 over 1. I can't go up 3 here, so I got to go down. 1, 2, 3, and left. Make sure you go left if you go down. 1, 2, 3, left. 1, 2, 3, left. All right, and yes, indeed, they are parallel. So, number 3, how many solutions does this have? How many times do these lines cross? They don't cross because they're parallel. So, this is no solution. Okay, so now we have seen no solution. We've seen infinite solutions if it's the same exact line. And we've seen one solution where they intersect and you name the point. So that is finally it for the notes today. No assignment today. We will just work on this tomorrow.